Today we're going to continue integration by substitution. This time we're going to talk about when we have a product or a quotient. So when there's two terms that are multiplied or divided, we use substitution. So examples of a product or a quotient would be the integral of x sine of x squared dx. Okay. So notice that it's a product. Okay, I have x times sine x squared. I also have x times e to the x squared, so I have a product. And then I have a quotient, 4x over 1 minus 2x squared over 2. We cannot separate these like we do addition and subtraction. We cannot take the integral of x and then the integral of sine x squared. We have to do u substitution with that. And because we have two terms, one of the hardest things that we do is what do we let u be? So u is always going to be the term, I should say 99% of the time, it's going to be the term inside a function. And by inside a function is I have two terms here. I have x and sine of x squared. This term inside the function would be x squared. For x and e to the x squared, okay, x doesn't have an inside function. E is a function, so inside the function would be x squared. So that's what we're going to let u be. For a fraction or a quotient, 99% of the time we let u be the denominator. And in this case, I have two things. I have the denominator and I also have inside the function. So that's going to be u. So let's do an example of how we would find using u substitution. So we already said that we're going to let u be inside the function. So we said let u be x squared. So we're going to take the derivative of u, just like we did before. So when we take the derivative of u, we're going to have 2x. So here's the new thing. We're going to have to multiply it by dx. So you always multiply like by dx. And then you're going to solve for dx. So we're going to divide both sides by 2x. So I end up with 1 over 2x du is equal to dx. So I'm going to go ahead and substitute everything back into my equation. I'm going to leave the x alone because I'm not going to substitute that. So leave it alone. So we're going to have sine of u because we're substituting u for x squared. And instead of the dx, I'm going to write 1 over 2x du. So notice my x's are going to cancel out. And I'm left with 1 over 2 sine of u du. So now it becomes a simple equation that I can take the antiderivative of. 1/2 is a constant, so I'm going to go ahead and leave it alone. So my antiderivative would be negative 1/2 cosine of u plus c. And then the last thing is I just have to substitute u back.